In this video, we will be talking about Riemann sums, primarily left, right, and midpoint. In our first example, we will approximate the area enclosed by f of x equals x squared plus 1, the x and y axis, and x equals 2, using left Riemann sum. To find the change in x, we will use the equation b minus a over n. Plugging in 2 minus 0 over 2, you get the change in x is 1. Beginning from the left, you will go from 0 to 1 and 1 to 2. You will use f of 0 and f of 1 as your main values. Once you have those values, you add them up and your area of the enclosed space is 3. In this example, we're going to use the same graph of example 1, but instead we will be using 4 sub-intervals and we're going to be using the right Riemann sum. To find the change in x, you do b minus a over n, which is 2 minus 0 over 4, and you get 1/2. So you multiply 1/2 by each f of x you will be using and then adding them up together. Since we're using 4 sub-intervals, our x's are going to be 1/2, 1, 3/2, and 2. After evaluating everything, your answer is 23 over 4. In our last example, we have hot water is dropping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t is given by a differential function c, where t is measured in minutes. Selected values of Ct, measured in ounces, are given in the table below. Using midpoint sum with 3 subintervals to approximate the value of 1 over 6 from 0 to 6, Ct dt. To find the change in x, use b minus a over n. You get 6 minus 0 over 3, which equals 2. Since it's 2, you will start from the first value, 0, and skip 2 each time. Since we're doing midpoint, you use the value in between each subinterval. In this case, you will use f of 1, f of 3, and f of 5. Remember to multiply everything by 1 over 6. Your answer is 10.1 ounces.